Hello everyone. Today we are going to be going over another super important way to solve equations in Algebra 1. And to do that, we're going to go ahead and take a look at this quadratic equation here. Quadratic meaning the x here has an exponent of 2 and there are some other terms in the equation, and it's also set equal to another constant. So I hope that this looks familiar from my past videos, as I've done some tutorials on factoring before. So we're going to go ahead and do a little bit of a review by solving this, by factoring out these two terms here, seeing what they have in common in regards to what they can be added up to or multiplied to. So this is again a technique I've gone over before. Be sure to check out those videos if you haven't already. So let's just go ahead and dive in before I explain more in depth about the quadratic formula, the alternative way to solve quadratic equations. Alright, let's go ahead and begin. So we're looking for two numbers that multiply to positive 15 and also add together to get negative 8. So I'm just going to go ahead and start listing out factors of 15 here. One of the most common pairs is going to be 5 and 3. And you may notice that ordinarily 5 and 3 would add to 8, but since we want them to join together to reach negative 8 here, I'm going to go ahead and make them both negative, so that when you multiply two negative numbers together, you'll still get this positive last number, but when adding them together regularly, you will reach a negative number. So once factored all together, I'm going to go ahead and write them out in the parenthesis groups. So here I have x minus 5, close parentheses, and x minus 3 equals 0. I'm just bringing down this 0 from the same equation. And now this here set of two groups represents this multiplied out equation. So when I'm looking to find the answer here, what I'm going to do is set each equal to 0. I'm going ahead and setting the x minus 3 equal to 0 over here as well. I'm going to add 5 to the side to reach the first answer, x equals 5, and adding 3 to this side as well to reach the answer, x equals 3. So both of these would be good answers to use here. So now we're going to go ahead and take a look at an equation that's not as easily solvable. So I'm going to go ahead and write it down here. Now I've already went ahead and set it equal to 0, so you don't have to worry about messing with this very last term on the end here, the 3, the negative 3. And I want us together to take a moment and try to factor it in the same way that we did up here. Okay, I hope you've taken a few moments in your head to just go through some of the factors of negative 3. You might have looked at negative 1 and positive 3, or negative 3 and positive 1. Those are the only two factors here, only two groups of factors that would work. But as you'll notice, they don't combine together to get that negative 7. So you may be at a loss here, wondering what there's to do next, since this factoring approach that is easier in my opinion, has not been working. Luckily, this is where the quadratic formula steps in. It is a very helpful tool. You'll see it often on formula sheets. It's something you don't want to forget, but will often have available to you. And it can be utilized to solve equations like these down here where factoring is not a possibility. So now I just have this same equation written out once again, and I'm going to go ahead and begin to dive into how we would use the quadratic formula to go ahead and solve this. When you see the quadratic formula written out, you'll notice 3 letters in it: A, B, and C. This A, B, and C set of numbers are not going to remain the same every single time you use the formula. Every time you have an equation like this one, you want to go ahead and use the quadratic formula to solve, you will assign an A, B, and C to the coefficients here in front of the numbers. So let me go ahead and change the color now. This space here in front of the x, or in the -3's case, the lack of x, will be your coefficients. So go ahead and let that sink in. Now, since there is nothing here, we're going to go ahead and assume that the coefficient of the x squared is 1, since 1 times x squared is equal to x squared on its own. In the case of the x to the power of 1 here, the coefficient we're looking at is -7. Oh, I apologize, I'm going to go ahead and write the coefficient we just discussed here underneath the a, or next to the a, since it is the number ahead of the x to the power of 2. And as I was saying here, the number we have in front of this is 7, but it's important to not forget that there's also a negative here, making the coefficient b value -7. And here it is plain to see that the c value will be -3. These are the a's, b's, and c's that we'll be plugging into the quadratic formula to solve this equation specifically. Again, it's important to remember that the a, b, and c will change every time you do a quadratic formula. You go ahead and work that out with a new equation. So just writing it out again here, I'm going to change the color once more. Your a will always be located in front of the x squared. Your b in front of the x, and your c alone when your quadratic equation is solved out in standard form. Now let's go ahead and move along and begin to solve the quadratic formula. So I have this here again. Let's go ahead and rewrite our a's, b's, and c's. The a is going to be 1 here. In this case, it's the coefficient of the x squared. B is going to be -7 as we discussed, and c -3. Now, I'm going to go ahead and reveal the whole quadratic equation now. The x, because remember, this whole time our goal is to get x by itself. That's why we factored before, and while we use the quadratic equation now, x is going to equal -b plus or minus the square root of b squared minus 4ac over 2a. So one at a time, let's go ahead and replace the a, b, and c constants with the specific ones we isolated up here from this written out equation. So I'm going to get rid of all the b's. And in their place, write our specific b, -7, -7. Now doing the same with the a's and c's. Getting rid of the a and c here, and the a at the bottom, and replacing them with our specific a and c's. Now that we have everything written out here, we're going to go ahead and move on to solving. Okay, we're going to start simplifying now by bringing down the x equals. So I'll go ahead and do that now. We're going to do a few steps at a time, but I'll be sure to go super slow so that everyone watching can understand what we're doing in each step. The very first thing I'd like to do is group together these two negative signs of the positive, and as we discussed a moment ago when we were factoring originally, two negatives are going to make a positive, so that'll leave us with +7 on the outside of the square root. We'll hang on to that plus or minus symbol. I'll go over how to incorporate that into finding your answer once we reach that step. I'm going to go ahead and write the square root now. I apologize for it being lopsided. But we have a -7 here in parentheses, and once again, we've discussed that two negatives make a positive, so it's essentially the same as squaring two positive 7s. So 7 squared would give us 49. Then we're going to go ahead and understand that anything times 1 is that same number, so we can essentially eliminate this 1 here, which will leave us with 4 times -3. And we'll leave this 2 in the bottom, since we just mentioned that multiplying something by 1 is essentially doing nothing to it. We'll go ahead and carry down the x equals and begin with our next steps. I'm going to leave this 7 plus or minus on the outside now still, because we're going to continue working on the inside of the square root. I'm going to keep 49 and then multiply together 4 and -3, which will give us -12. So I have minus -12. 2 minuses make a positive, so I'm going to go ahead and transform this into one large positive. We'll go ahead and leave the 2 on the bottom of that now as well. Continuing to simplify inside this square root, I'm not doing anything else yet. I'm going to go ahead and rewrite the beginning of the equation. X is equal to 7 plus or minus the square root. Now I'm going to go ahead and add 49 and 12 together. And that is going to give us 61 over 2. Now, we are almost finished. Now is when the plus or minus here is going to come into play. I'm going to go ahead and split up the answer, writing everything exactly the same, but once without the minus and once without the plus. So x is going to be equal to 7 plus the square root of 61 over 2. and then x is also equal to 7 minus the square root of 61 over 2. And I'm not going to even attempt to break up these square roots. So what you would do if you wanted to find an exact answer is go ahead and plug this into your calculator, and it would give you the decimals of the exact value, but we are done now with the quadratic formula. We can think back to when we just began. We used this formula and replaced the physical letters A, B, and C with our specific letters that apply to the original equation here, x squared minus 7x minus 3. And instead of having our answers given to us as nicely as they were here originally, x equals 5 and x equals 3, we have a new case of answers in which they're in a new form. There's a fraction and a square root in them, but don't let that fool you. These both will be our final answers. Now I'm going to go ahead and continue on with our practice of the quadratic formula. I'm going to throw up a new equation here on the blackboard and go through our steps just to review what they were. So here it is. I'm going to write 3x squared plus 2x plus 5 equals 0. Now I'm just changing the color, and I'll write out our steps so you can take an easy screenshot of what to do. So first and foremost, I always like to check if factorable. Because I like the quadratic formula, however, just factoring an equation is a lot simpler. So in this case, I'm looking, 5 is sort of a prime number. Its only factors will be 1 and 5, and those do not add up to 2 in any way, shape, or form. So it is not going to be factorable. Also, to add, there is a coefficient here in front of the x squared, so that would complicate things as well. I think the best course of action here would be to proceed with the quadratic formula. So our second step, after we decide it's a good candidate for the formula here, is to assign the a, b's, and c's. Once we've done that, I'll save it. I'll save actually doing it for when we do the formula after I list out the steps. After that, we're going to go ahead and plug in. Plug into that equation. We're going to replace our specific A, B, and C's with the real letters. And then lastly, we're going to go ahead and simplify. Sometimes there are cases where you are able to simplify that number within the square root further than I did in our last example. You never know until you get there. So with these steps here in mind, I'm going to go ahead and delete them so we can go ahead and work through this problem together nice and slow. Practice what we just learned. Alright, we already determined this is a good candidate for the quadratic formula, so I'm going to go ahead and proceed to step 2, which is assigning the a, b, and c. Looking back here, the a is going to be next to the x squared, b next to the x, and c on its own. So there are not even any negatives here. I believe it's easy to pick that a, b, and c out from the crowd. A is going to be 3, this number here. next to the x squared, our 2, aka b, is here. And c on its own is going to be 5. I'll go ahead and write out the quadratic formula now, since our next step is going to be to plug it in. X equals negative b plus or minus the square root of b squared minus 4ac over 2a. I'm going to go ahead and switch this back to red just so we can distinguish that we're using our original equation now, the a's, b's, and c's that we got from it. So I have now x equals negative b. I'm not going to write it out once more with the a's, b's, and c's. I'm going to go ahead and replace it immediately. So we have negative 2 starting off the equation. Bring that same plus or minus and large square root symbol down. B, 2, and we're going to go ahead and square it here. Minus 4, and we're going to add our a value and c value over 2a. Alright, I'm going to go ahead and clear my workspace. Now that we've got everything plugged in, solving and simplifying is really the last step we're going to do with this problem. Okay, just bringing down this x equals and negative 2 since there isn't much we have to do. We originally started with a positive b, so we're just going to make a negative, that is all. That plus or minus, I'm going to go straight to working in the denominator and underneath the square root symbol. 2 squared is going to be 4, and from that we're going to subtract 4 times 3 times 5. I'm going to do that in 2 steps, so we have negative 4 times the answer to 3 times 5, which is going to be 15. And on the denominator, we're going to multiply 2 times 3. That'll just get us positive 6. Now, bringing down the beginning of the problem once again, I'm just going to start off with this and continue to work through what's in the square root. So I have 4 minus 4 times 15. That's going to be 60. As you can see, it's starting to give us a little trouble here, but I'll continue on with the equation, simplifying what's in this square root some more. A big red flag here is going to be a negative within the square root, which will make this quadratic equation have no solutions. So you can just go ahead and write no solutions down here for your answer, and that's good. We've shown all our work and are ready to go ahead and carry on. Now I'm going to go ahead and give you a quadratic equation to work through on your own. here it is, except I'm not gonna give it to you in the same easy format we've worked with in the past examples. We're instead gonna apply our general knowledge with solving equations to get this in the right shape to solve using the quadratic formula. 3x squared minus 3x plus 7. We're going to set that equal to 9x plus 3. Now, I want you to take your time looking at this problem, starting by grouping together like terms and setting it equal to 0. That is a hint for you to get started with it. Then go ahead and proceed with the 4 steps we talked about. However, I do want you to use the quadratic formula here, so even if it is a candidate to be solved in a different fashion, go ahead and skip over original step 1, which was determine if it's a good candidate, and go ahead and proceed with the formula by assigning the A, B's, and C's. So I'll go ahead and give you some time to get started in this problem now, and as the time goes on, we'll check back in with you and work through the problem together. We'll go over our answer and make sure we got the same thing. So go ahead and take your time to do that now. Okay, while you're working, I'm going to continue solving this problem, or sorry, begin solving this problem. Like I said, starting off by grouping like terms. I'm going to subtract at once a 9x and a 3 from the right side of this equation just to bring those over here. Now that we have the right side set equal to 0, I'm going to go ahead and start on using the quadratic formula. This 3 here is going to be my A, negative 12 my B, and 4 C. Going to go ahead and plug that in to the quadratic formula we've been working with this whole video. I'll write it here on the side just for reference in case we haven't memorized it yet. X is going to equal negative b plus or minus square root of b squared minus 4ac over 2a. Now switching back into my red, we're going to go ahead and keep solving. Setting x equal to negative b. Since b is already negative, it's going to be positive 12 plus or minus the square root of negative 12 squared minus 4, our a and our c, over 2a. 2 times 3 is 6. Now we're going to carry our x down and continue solving now. 12 plus or minus. We're going to square negative 12 here, and since 2 negatives make a positive, it will be 144 positive. Now we're going to do this next step all at once. So we're multiplying 4 times 3 times 4. If you want to do the 4 times 3 equals 12, and then multiply that by 4. If that's simpler for you, definitely do that. So we'll have 144 minus 48 here in the numerator, then the 6 on the bottom. Carrying down this x, we're just going to continue working. 12 plus or minus 144 minus 48. Now here we're going to go ahead and write in to finish off this first step of simplifying our numerator. So we'll have 12 plus the square root of 96 over 6. Luckily, we're able to break 96 into a perfect square. So now I'm taking a 16 and a 6. These two factors multiply together to get 96. So we'll keep our 12 and our plus or minus. But then, since the square root of 16 is 4, we'll go ahead and bring a 4 to the outside here, leaving a 6 in the square root, and then a 6 is on the bottom as well. There is some simplification to be done here. We're not quite finished. I'm going to go ahead and remove a 2 from every number here. We're going to not take one out of this 6 here, since this 4 root 6 is technically one term. So removing a 2 from the 12 will give us 6. Keeping our plus or minus, keeping, this is one term, we'll just take out a 2 from it as a whole. So that'll leave us with 2 root 6 over 3. I'm going to go ahead and break up this plus or minus once again to give us our final answer. X can equal 6 plus 2 root 6 all over 3, or x equals 6 minus 2 root 6 over 3. Now, looking at this problem, I'm wondering if I can even simplify it a bit further. So I'm going to delete these two answers here and separate the denominator. I'll disperse that amongst the terms of the numerator. So we'll have x equals 6 over 3 plus or minus 2 root 6 over 3. Since 6 over 3 is 2, we'll have 2 plus or minus 2 root 6 over 3. And we can go ahead and break that up into the two terms using what we learned about the plus and minus, but I'll go ahead and call it there. That has been our practice with the quadratic formula. I hope this cleared up a couple questions that you may have had, or confusion about solving quadratic equations that aren't easily factored like we did in our review of this video. That's going to be all for today.